The second question, logarithm of 8 to the base of 4. It becomes 1 over logarithm of 4 to the base of 8. 4 and 8 can be further broken down to the base of 2. So we have 4 to be 2 raised to the power of 2. We have 8 to be 2 raised to the power of 3. When we apply the power rule, that when you have the power of a logarithm, it goes behind. So we have 2 logarithm 2 to the base of 2 raised to the power of 3. Applying the rule, which also states that when we have the power of a base, it comes behind as a reciprocal. So we have 1 over 2 times this comes behind as a reciprocal times 1 over 3 logarithm of 2 to the base of 2. So this comes 1 over 2 times 1 over 3, 2 over 3. Logarithm of 2 to the base of 2 is 1. So this gives us 1 over 2 over 3. 1 divided by 2 over 3. When we have 1 over 1 divided by 2 over 3, this gives us 1 over 1 times 3 over 2. Our answer is 3 over 2. So we come to the eighth rule. The eighth rule, yeah. Change of base. The rule states that when we have logarithm of x to the base of a, it becomes logarithm of x to the base of a over logarithm of a to the base of a. So we are asked to simplify logarithm of 3 to the base of 2. This okay. Okay, so we transform this to common logarithm. So we have this as logarithm of 3 to the base of 2 over logarithm of 2 to the base of 2. Now, logarithm of 2 to the base of 2 is the same thing as 1. So we want to transform this to common logarithm. When we talk about common logarithm, we are talking of logarithm with base 10. Logarithm with base 10 generally is referred to as common logarithm. Now, this is the same thing as log 3 base. The same thing as log 3 base 2 over 1, because logarithm of 2 to the base of 2 is 1. Applying this rule. Now, in order to solve this, because this still gives us the same thing, we want to transform it to a common logarithm, knowing that we have 1 here. When you talk of logarithm, knowing that we have 1 here, if we want to transform to common logarithm, 1 is the same thing as logarithm of 10 to the base of 10. Now, why I'm saying this is because we said we want to transform this to common logarithm in order to solve this. The logarithm of 10 to the base of 10 is the same thing as 1. Now, so let's say we have logarithm of 3 to the base of 2 over logarithm of 10 to the base of 10. This isn't where we are going. I'm just trying to explain. Now, in order to transform to solve this, we apply base 10 to our numerator. When we apply base 10, don't forget that we said 1 is the same thing as logarithm of 10 base 10, because this gives us 1. Now, when we apply common logarithm to this, it becomes logarithm of 3 to the base of 10 over logarithm of 2 to the base of 10. That was why I was trying to explain that this logarithm of 10 to the base of 10 becomes 1. So we've actually eradicated 1, because in the long run, logarithm of 3 to the base of 2 over 1 is the same thing as logarithm of 3 to the base of 2. But applying common logarithm to this makes it become logarithm of 3 to the base of 10 over logarithm of 2 to the base of 10. Now, when we use our logarithm table, or you use your calculator to check for the logarithm of 3 and then the logarithm of 2, it gives us 0.4771 over 0.3010. When we divide this, answer at 1.5849. So we transformed this to common logarithm. That's why we said change of base. There was a change in the base. The base changed from 2 to common base, which is 10. Then the last example, logarithm of, the last rule, logarithm of 1. We said that the logarithm of 1 to any base is equal to 0. Okay, okay, example 9. The logarithm of 1, logarithm of 1 to any base is 0. So if, for example, we have the logarithm of 1 to the base of 1000, our answer is 0. We have logarithm of 1 to the base of 10, our answer is 0. Because if you transform this to indices, we have it as 10 raised to the power of 0 is equal to 1. If we also transform this to indices, we have it as 1000 raised to the power of 0 is 1. You know, logarithm is just like the opposite of indices. And in indices, we said anything raised to the power of 0 is 1. So in logarithm, the base of 1, or how should I put it, logarithm of 1 to any base is 0. Do you understand? Do you understand?
Yes, ma'am.
I did not ask. Can I clean the board? Are you
Just
done
a
right
minute,
now?
ma'am. Just a minute, ma'am. Just a minute, ma'am.
Can I clean the board? Can I clean the board?
Yes, ma'am.
of 0. We said logarithm of 0 is undefined. So if we have, that's the rule. So if we have logarithm of 0 to the base of 10, it is undefined. If we have logarithm of 0 to the base of 3, it is undefined. Logarithm of 0 to whatsoever base is undefined. Logarithm of 1 to whatsoever base is 0. So that will be all for rules of logarithm. Can I clean the board? Let me continue.
Madam, can you hear me?
Yes, I can.
Oh, okay, okay. I thought you were muted. Okay, you can continue.
Now, what this place is trying to say, we are talking of common logarithm. Like I explained earlier, we said the most frequently used logarithm is to the base of 10. So when we see most logarithms are always in the base of 10. So they are referred to as common logarithm. And most times they are not written. They are always omitted. So example now, you see logarithm of 100 to the base of 10 is written as logarithm of 100. And logarithm of 10 to the base of 10 is written as logarithm of 10. So any logarithm where you don't see a base, it is assumed or believed that that logarithm is to the base of 10. So that's why we call it common logarithm. That logarithm is what is believed to be to the base of 10. Any logarithm where you are not giving the base. So for example, you just see them write logarithm of 25. Or you see them just write logarithm of 2. It is assumed or believed that this logarithm is to the base of 10. So base 10, sometimes written, or most times omitted. So that is that for common logarithm.
Ma, I have question, ma.
Okay. I can hear you. Hello? Hello?
Talking.
You said?
What if they gave us like addition of log? They gave us one base and they gave us
If there's one without base and then there's one with, okay, maybe something like this, logarithm of 25 plus 3 to the base of 5.
yes, ma'am.
But you cannot be given any question like this if they won't give you a base, because why I said so is because this is logarithm to the base of 10, and this is logarithm to the base of 5. And quotient rule, product rule is not used or applied. It is inapplicable for different spaces. You can
Yes,
only
ma'am.
use rules where you have the same base. So you cannot see any question. You can use your calculator, your scientific calculator. Maybe they'll give you a question like this. That means they're expecting you to solve it using your calculator. Because even our logarithm and anti-logarithm is always to the base of 10. Logarithm, anti-logarithm, it is to the base of 10. That is the general base for our logarithm table, logarithm, anti-logarithm. So in this case, you can only solve using scientific calculator, or you change this. Okay, you change this using the, what's it called? Change of base rule. We just talked about change of base rule. In that case, this changes and you apply the common logarithm. So this becomes logarithm of 3 to the base of 10 over logarithm of 5 to the base of 10. Do you understand? So if you apply this rule, you use
Yes, ma'am.
your
Yes, ma'am.
logarithm table or your calculator to get the logarithm for 3, get the logarithm of 5, then you get your answer. When you get your answer, now I'm just saying, I'm not saying that's correct answer. So if peradventure when we solve this, we got 1.2984, this is not the correct thing. I'm just assuming this is our answer. Now, and we know that this is in base 10. So now we use our logarithm table to also check the logarithm of 25 to the base of 10. Use your calculator or your logarithm table, and you have this one to be maybe 2.894. That way you can add up. But this is not really, how should I put it, feasible, because you are not applying the logarithm rule. The logarithm rule states that addition changes to multiplication. Do you understand? So if we use this method I'm talking about, we are going by direct addition. But for the product rule to be applicable, your base must be the same. Do you get it?
Okay, yes, ma'am.
So now we move to
Hello, ma.
Hello.
Yeah, you have 9 more minutes.
Yeah. Um, we're talking about using tables to find the logarithm of a number. That is in your four-figure table. So it said if a number is expressed as a power of 10, then the index is called the logarithm of the number. If a number, for example, 69, is expressed as a power of 10, that is 10 is the base, and we have the power. Then the index, this is the index or power, our index of power. Then the index is called logarithm of the number. So that is number is equals to 10 raised to the power of the logarithm. Sorry. It's just like the normal logarithm we've been doing all along. We said when we have logarithm of, let's say, logarithm of x is equal to y. We say it's the same thing as saying what a raised to the power y is equal to. The base remains the same while the number and the logarithm is interchanged. So if you can remember, this is what God always said. So it's the same thing they are saying here. So you have your number, your base is the same. So we have number is equal to 10 raised to the power logarithm. So in this case now, we know that here our logarithm is x. So the number, this is the number. This is our logarithm. And this is the base. Sorry, this is the logarithm. This is the number. So our number is equal to 10 raised to the power of what? Your logarithm. So if, for example, we have 69 is equal to 10 raised to the power of 1.8388, that means the logarithm of 69 is what? 1.8388. That is the logarithm of 69 is 1.8388. When you use your four-figure table to check that, you will confirm. So I'll stop here for today. Next class we'll give some other examples. Any question so far? Any question? Okay, in the absence of any question, this is the end of today's class.